And I want, so you are welcome again to this very interesting edition of Learning Chemistry with Moses on this online meeting. So I know you are all agitated to resume back to school, and that is going to happen very soon. So I presume our last week, okay, supposing you're in school, we are through with first week now. So this is second week. So just taking this opportunity to share with you our first week subject, which is Introduction to Chemistry. Okay, so I'm going to do that introduction briefly today, and we are going to have a very nice and lovely time learning chemistry. Okay, so can you see my full screen now? Beautiful. Can everybody see my screen? Hello, if you can see my screen, let me hear your voice. Who is here?
Yes.
Beautiful. My name is Moses. Who is there? Mine good Daniel is around.
Yes. Yes.
Beautiful. Remy Eko, who is that? Ngozi is there. Beautiful. So our topic for today is introduction to chemistry. Okay. Let's just have some decorum from your end so that we'll have a very nice session. Introduction to, that is what? Chemistry. So let's see, what are those things that we are going to learn today in our chemistry? This is our learning objective for today. Some of our learning objective is going to include, we are looking at the subject, chemistry as a subject. We will look at the branches of chemistry, and we talk about scientific method and laboratory apparatus. Scientific method and laboratory apparatus. So we are going to cover these 3 or 4 things as we move quickly in this edition of Learning Chemistry. So I hope you have jotted some things down. So this is what we are going to cover today. Okay, please let's mute our, so we can mute our microphone now. We can mute our microphone now. Let me mute everybody. Okay, so that we can have a very neat session. Beautiful. Okay, so these are our learning objectives as I stated before. We're going to define chemistry as a subject. We're going to look at branches of chemistry, and we're going to look at some of the scientific methods and laboratory apparatus. Okay, so let's move on. Let's move on now. So let's move on. So if you want to define chemistry, say what is chemistry? What is chemistry? This is the definition here. But before then, I will go to science because chemistry is a science subject. So we are looking at chemistry as a science subject. See, chemistry is an organized body of knowledge. Look at the word, organized. It's not scattered. It's not higgledy-piggledy matter of arrangement of things. It's organized body of knowledge gathered through systematic experimentation as philosophical observation. That is science. So for you as a science student, you must be organized, you must be ready for experiment, and you must be able to think. That is philosophy. You must be able to think and observe. Observation is different from looking. You may be looking at a concept and you are not observing it. So observation is very, very important as a science student. You get that? Beautiful. Now let's move on. So if somebody asks you to define chemistry or you want to jot it down, what is chemistry? You say chemistry can be defined as a branch of science which deals with study of nature. Number 1. 2, structure, what that matter composes and its properties, and the changes that takes place when those matters are subjected to different conditions. Beautiful. That is chemistry. That is chemistry. So you say chemistry can be defined as is branch of science which deals with study of nature, structure, composition, properties, and uses of all forms of matter, and the changes that matter undergoes when they are subjected to different conditions. So you can underline some of these subject words here: nature, structure, composition, properties of what? Of matter, and the changes that matter will undergo when they are subjected to different conditions. That is chemistry. Let's move on. Beautiful. I hope you jotted something down there. Okay. Now, what are the branches of science? Look at the branches of science that we have. 3. The physical, the inorganic, and the organic. The physical chemistry, the inorganic chemistry, and the organic chemistry. I'm going to explain this in this subsequent one. Look at what is physical chemistry here. It deals with the physical aspect of chemistry like quantum theory, heat, electricity, whatsoever. Physical means things you can see, relate with. Okay? The organic deals with carbon and its compound, hydrocarbons, whatsoever. Organic chemistry, when you begin to talk about alkanes, alkynes, carboxylic acid, this and that, those ones are structured under organic chemistry. Are we good? And then the inorganic chemistry deals with the studies of elements and their properties, including their uses. Today, cars are built, aeroplanes are built with different metals. Don't forget, the metal used in construction of cars is not the same metal you use in construction of aeroplanes. The metal you use in construction of aeroplane is not the one you use to construct ships. So there are so many different things. So in inorganic chemistry, you are dealing with elements and their properties, including uses. So before you can use a particular element in a system and say, okay, I want to use this element to build this system. I want to combine this element with this element to form an alloy and build this. You must understand their properties, and then you will be able to use them effectively well. Okay, so I hope you are enjoying systematic introduction to chemistry as we move on. Okay, so that's fine. That's fine. That's fine. Let me move on now. Now, I'm going to talk about this before I move on. As a science student, what are those patterns? What are those things that you need to do? How? Do you know? Now, you know some laws. For example, you know law of gravity. There are so many laws in chemistry. Charles' law, Boyle's law, Gay-Lussac law, Avogadro's law, Faraday's law, Le Chatelier's principle, and so on and so on and so forth. How does this law come to be? This law, how did they come to be? These are the steps that those laws were being generated in chemistry. Number one, you know, I told you something before, that science student must be able to observe. That you are looking at something does not say you are observing that thing. No. Are you getting it? That you are looking at something does not say you are observing that thing. Look at it here. Observation. Science observes. So as you are looking at a concept, you'll be equally thinking, am I not observing it? So that is observation. So you want to develop a law. Before a law comes up, you first start with observation. When you observe, you've defined a problem. There is a pattern that things will take around. Maybe something is always going from left to right, left to right, left to right every time, left to right every time. Why is it this thing always going from left to right every time you observe? You check the pattern. And then you come with a problem and say, okay, this is a problem. We don't want this thing to be going from left to right. I want it to be coming from right to left each time it starts. Okay? So you identify a problem. After your identification of problem, you state an hypothesis. Hypothesis is just a hunch, a proposition that is going to guide you. A hypothesis is just a hunch or a proposition that is going to guide you as you begin to form postulations, as you begin to experiment. Some of your, okay, let me give this example. Let me say example. All cars have engines. All cars have engines. In science, they will just say that is just an hypothesis. You begin to check all the cars around, open their bonnet and begin to find out, is it true they have an engine? Is it true they use this plug or whatsoever? Do you understand? So you just form a proposition and say, okay, the earth is round. For example, it's just an hypothesis. You begin to test it. Are you going to conduct an experiment upon it? Are you going to walk through the whole earth and see, is it round? Are you going to use a camera? Are you going to fly a drone or do something? After that, hypothesis, you come to experiment. And when you do experiments, upon your hypothesis and say, oh, all cars have engine, you begin to open some of the engines around you and check, and they truly have engines. Then you have conducted an experiment. That becomes a theory. It becomes a theory. It has not become a law. It becomes a theory because you have only checked all the cars around you. You have not checked all the cars in Ghana, in South Africa, in London. Maybe they equally have engines. Are you getting it? Because at the ambient of what is at your disposal, you can say that, okay, I have found out that all the cars around me, with the ambient provision that I have, they have engines. You form a theory. You form a theory. Then, if your theory now goes universal, that your theory is correct in Nigeria, it's correct in Africa, it's correct all over the world, then it becomes a law. It becomes a law. Are we good? So this is how it occurs. Observation, you state your problem, hypothesis, experiment. Sometimes you need to conduct further experiment. You construct further experiment and check again and again and again and again and again. And then you form a theory in your locality. Okay? And then the theory now goes universal. Everybody now say, oh, it's correct in Africa, all over the world. It becomes a law. For example, the law of gravity in science, the law of gravity. What goes up comes down. It's a law. You know, if you throw a spanner up in Nigeria, it goes up, it jumps down. You go to Ghana, you throw something up, it comes down. You go to South Africa, you throw something up, it comes down. You go to London, you throw something up, it comes down. And then they now say, oh, this only has been universally proven. It becomes a law. So that is scientific principle. I hope you understand that. Now, if you study chemistry very well, you resume back to school now, you study chemistry very, very well. What are you going to do with chemistry? That's what we are looking at. Career prospects in chemistry. Career prospects in chemistry. What are you going to come up with? Study your chemistry very well, you can become a pharmacist. Then you'll be developing drug for us. When people are sick, you develop drug. You can come to science education and become an erudite teacher like Mr. Moses. Okay? Begin to teach science, teach coding, teach robotics, whatsoever and whatsoever. If you study chemistry very well, you can equally become a chemical engineer. You know, I studied this. This one is in red because this is my field. And I want as many of you to become a doctor, an engineer, especially. I want you to become chemical or petrochemical engineer. Okay? So that we begin to solve problems for us in Nigeria. So you can be in education, you can be this, chemical engineer. You can also be in mining and metallurgy, people that look for raw materials from the soil, help us extract, refine, do this, do that, and construct for us. You can actually be in research, which is a pure and applied chemistry. There are some of the branches that you can fall into if you study your chemistry very well. So being a chemist, if you study chemistry very well, you have endless opportunity in science. Are you good? Endless opportunity in science. Beautiful. What are other careers opportunity? Look at them here. You can be a petroleum or petrochemical engineer. You can be in quality control. People that will help us after, for example, somebody develop a drug. A control officer is going to go and test that drug and say, okay, this thing has been standardized. This thing is fine. You can use it. Okay? I develop a metal. I develop a material. Somebody is going to test. So you can be a control engineer. You can be a quality person. Okay, you can actually be in medicine and surgery if you study chemistry very well. It's one of the backbone in surgery and medicine. So some of you that want to go to medicine, you want to become a doctor, whatsoever, please, you have to take chemistry very, very well. You can actually be in analytical science, forensic, people that are going to test, nanotechnology, can be a biochemist, can be a laboratory assistant, can be even an environmental person. Those are some of the career prospects that you can be, that you can get if you study your chemistry very, very well. Do you understand that? So if you study chemistry very well, these are some of those things that you can become. And that is a brief introduction to chemistry. I want to ask you from all of this now, so you are going to unmute your microphone. You have seen some careers. You have seen a beautiful part of chemistry. I'm going to ask you some few questions now that, I didn't talk about this. So I want you to brainstorm and think. What do you think can be effects? So please, you unmute your microphone now and tell me some of the effects. I have talked about application. I have talked about careers. I have talked about branches. I have defined science. Look at this. We are all going to brainstorm and look at, does chemistry have an adverse effect? Does it have anything that is negative? That is what we call adverse effect. Okay? So we are going to talk about that now. Let me go back to our page and see who is around. Bajulaye is around. Mayugbe is around. I trust Ogeshi will always be around. Beautiful. Ogechi, my Olympiad, can you please unmute your microphone? Ogechi, please unmute your microphone. Are you there? Ngozi?
Sir.
Beautiful. So you have listened to the lecture?
Yes, sir.
But I skipped something. I skipped the adverse effect. That is what I want us to brainstorm before the end of the section. What do you think are the adverse effects, as in the negative side of science? Can you please tell us one? Do you think science has a negative effect?
Any negative effect?
Yes, any negative effect? Ngozi?
Yes, sir.
Do you think science has any negative effect?
Yes. Yeah, in some cases it can have negative effects.
Oh, beautiful. Do you think, can you think of anyone?
Yes.
Can you think of anyone?
Chemicals. Misuse of chemicals.
The use of chemicals. In what area? You're online, oh. I love your thinking.
Yes.
The use of chemical in what area?
Like mixing the wrong chemicals together, combining the wrong acids.
So that can give a negative effect.
Yes, sir.
Oh, you are almost there. You're almost there. Let's see. Sandra is there. Greg? Sandra. Let's hear from Sandra. Okay. Bajulaye is raising up his hands. Bajulaye.
Yes, sir.
Yeah. Negative effect of science.
Pollution.
You are beautiful. You are brilliant. Brilliant.
Thank you, sir.
Brilliant. Pollution is one of the negative effects of chemistry. You see, when we produce all these chemicals, sometimes when they get to the environment, they are not environmentally friendly, especially when they enter into bodies of water or even air. So pollution is one of the adverse effects of chemistry. Bajulaye, another thumb up for you. Great. I will be expecting you in school. And I hope you are going to be one of the best science students. Beautiful. Thank you very much. Let me go to
Thank you, sir.
Adebowale Adedoyin. Adebowale Adedoyin. Please, can you give us one negative effect? Yes. Unmute your microphone and give us one negative effect. Adebowale, unmute and talk. David is raising up his hands. Okay, let's pick David. Olale David. Unmute and talk.
Atomic bomb production.
Atomic bomb production war is a negative effect. Look at what is happening in Ukraine. Look at what is happening in Ukraine and Russia. Do you understand? Those are negative effects. Mass destruction. Sometimes science causes mass and massive destruction. Beautiful.
Thank you, sir.
Beautiful. Thank you very much. Thank you very much, David. Let me pick another person. I think who is using engineer Remi's phone. Oh, this person is going to be an engineer like me. Who is that person? The person using engineer Remi Eko, unmute and talk. Give us just one negative effect of science or chemistry now. Please unmute if you can hear me. Unmute and give us one negative effect. So somebody has talked about pollution. Somebody has talked about atomic bomb, that is war. Engineer Remi, son or daughter, can you give us one? Please unmute so that we can talk. It's now evaluation time. It's now evaluation time. Please unmute and talk before our session is over. That is our brief introduction. Okay, who wants to give us something again? Let me see. Do we have any hand up? Not yet. Olale. Mine go David. Mine go Daniel. Can you come again?
Depletion of ozone layers.
Depletion of ozone layer, which is also a pollution from some of this industry, heavy smoke from chimney, flaring of gases and so on. Man, you are brilliant. Depletion of ozone layer, and you know that causes global warming. As soon as ozone layer depletes, global warming starts. Beautiful. Thank you very much. So those are some of the negative effects of chemistry or science as we know. So when you finish studying your science and you become an engineer, a doctor, don't forget drug abuse too is also a negative effect. Drug abuse is a negative effect. Are you getting it? There are some negative drugs in the circulation. There are some of those negative effects that you can talk about in chemistry because they all emanated from chemistry or science production. Are we good? So that is that for our study. So let me go back to our template and do a brief round up again. So now, can somebody define for me what is chemistry? What is chemistry? Let me pick somebody. If you have jotted anything down, what is chemistry? Mind, can you try?
Chemistry can be defined as the study of science. Is a branch of science that can be defined as the study of the nature, structure, composition, and properties and use of fumes.
Beautiful. A body of science that is organized, that deals with the properties and what those materials undergo as soon as they are subjected to different changes. It studies nature, it studies structure, composition, and property of matter. Don't forget, matter is anything that has mass and occupy space. Fine. What about branches of science? How many branches of science do we have? How many branches of science do we have? 3. What are they?
Physical,
Physical, one.
Inorganic branch
Inorganic
and organic.
and the organic. And the physical, inorganic, and the organic. Those are the three branches. So let me come to it here. So that is what you are seeing there. The physical, the inorganic, and the organic. Beautiful.
Organic.
At what point will you say a science proposition is a law? When will you say a proposition is a law? When does it become a science? Yes.
After the carry
When do you say a proposition is a law in science?
after the carry after the carry test and they see it's fine.
Yes.
How they pass it every and they see it's correct.
Okay. Is it when it's correct in small locality or when it's correct universally?
When it's correct universally.
Beautiful. Beautiful. When it's correct universally, it becomes a law. If it's correct at the ambient of what is available to you, that is just a theory. Are you getting it? That is just a theory.
Yeah.
And
Yes,
the statement you start with, the statement you started with is the hypothesis. You know, you have to say something before you start experiment, Abby. Let me say
Yes.
salt.
Yes.
All salt taste bitter. It's just a proposition. I have to start testing salt and see is it true they are bitter or they are sweet. So when they now find that they are now sweet, then that hypothesis will not stand. Are you getting it? So that's
Yes,
how.
sir.
So when it's
Yes, sir.
universally correct, it becomes a law. But when it's correct at the ambient of what you have, at the ambient of what
It's
you
a
have,
theory.
yes, it's just a theory. Then the one that you started with, that proposition you started with itself, is the hypothesis. Hypothesis. So there are three things there: hypothesis, the theory, and the law. That's where you see something about Charles' law, law of gravity. Are you getting it? Those ones has been universally
Yes,
proven that they are correct and they are correct. Can somebody tell me, if somebody study chemistry very well, what are those things that you can become in future in the next 4 years? What are those things that you think you can become? Let me see. If you study chemistry very well, what are those things that you can become?
Engineering.
In engineering, beautiful.
Chemical.
You can become a chemical
You
engineer.
can become a chemical miner.
You can work as a mining engineer.
You
Good.
can become a pharmacist.
Quality control personnel.
You can become a quality personnel. You can work as quality personnel, and that is where there is big money in quality now. There is big money in quality. So some of you, I hope you grow up to become a quality engineer. They'll be looking for you, testing materials up and down, and you will make good living from there. Okay, so those are some of the careers and some of those things we have in chemistry. So that's our introduction for today. I shared the link. Have you checked the link? Hello everyone. I shared the link. Have you checked those links?
Yes.
I shared the link on the WhatsApp group.
So, is it on WhatsApp?
Yes, I shared the link on WhatsApp. Have you checked them? It's an app. Okay. If you have not checked them, please check it. You go to www.mosesadewale.com/chemistry. Okay. I compress some of the I compress some of the questions that you see in first time there. So, and it's very interactive. When you click on something and you don't get it, it will tell you that you didn't get it, and it will show you the right answer. Do you understand? So, all the level participants, everybody here, what you are going to do now is by tomorrow, you go to that app. Are you getting it? The link is on the WhatsApp group. Okay. Even this night, do something and send a screenshot of your end result. Send a screenshot of your end result. Yes. Send a screenshot of your end result when you are done. Do you understand that? Just send a screenshot of what you got. Okay. back to the WhatsApp so that I can know that
Okay, sir.
you are working on it. So I hope I'm going to see about 11 or more than that. I'm going to see about 11 screenshots at the end of this class. Do you understand? So please go there. The link is still on the WhatsApp. I will share it again at www.munzadali.com/chemistry. Okay, so you relate with it very well. Before you come to school at all, I want you to be very grounded very well. You must be very, very grounded. And then we are going to have another meeting before you resume. So that will cover our second week topic. Do you understand? Until we get to nature of matter and so on. So you'll not be lacking at all. And I may even drop your notes. Are you getting it? I may drop
Yes,
your
sir.
notes. Yes, I may drop your note for you so that you can copy those notes before you come. Is digital world? I love the way you are responding on internet. I love the way you are learning through technology. It's best of the thing that is happening around now. And that is what we encourage some of our students to do, to be able to learn online, not going online to just go and look at Facebook, watch film, watch videos. No. But be online and get quality academic content. So that's our take and our lesson for today. I thank you all for coming, and I appreciate your parents for giving you the opportunity to join the class. God bless you. In the next 4 years, I want to see many of you becoming doctors, engineers, quality control person, and so on and so on, pharmacists, improving the quality of education in Nigeria. I want to see many of you becoming teachers, educators who are going to improve the quality of education in Nigeria. And so shall it be. So thank you for coming, everybody. God bless you and have a wonderful night rest. God bless you all.
Amen.
Okay, sir.
Amen, sir.
God bless you.